Polymorphism. What is polymorphism? Polymorphism is defined as a single action to be performed in different ways. What does this mean? You have a single action. For example, starting a vehicle is the action. Start is the action. But when you start a car, this action is performed in a totally different manner compared to starting a bike. Bike starts in different manner. So the action is same. Action is start. But the implementations for two different objects, car and bike, is different. So single action to be performed in different ways is called as polymorphism. Types of polymorphism. In Java, there are two types of polymorphism. First is compile time polymorphism. This is also called as static polymorphism. Compile time polymorphism is achieved by method overloading. We are going to see what is method overloading. Second type of polymorphism is runtime polymorphism. This is also called as dynamic method dispatch. Runtime polymorphism is achieved by method overriding. Class has more than one method with same name but different signature, where signature can differ by number of parameters, type of parameters, or both. Compile time or static polymorphism is achieved by using method overloading. So let us try to understand this definition. When you are implementing method overloading, you need to follow some rules, and the rule is a class has more than one method with same name. For example, a class has a method named add. Return type is void, and this method is not taking any parameters. A class also has a method with same name, but in this example, there are two parameters of type int. So this is the correct example of method overloading. Both the methods have same method name but different signature, where signature can differ by number of parameters, types of parameters, or both. So in this case, there are no parameters, and in the second example, there are two parameters of type int. Now look at the third example. Here, the method name is same, and the method has two parameters, float, comma float. So there are two float parameters. Now again, this is a valid example of method overloading, because in the second example, there are two parameters. In the third example, there are two parameters, but the type of parameters are different. So method overloading can happen with same method name, but it should differ in number of parameters or types of parameters, or both. In the fourth example, you have same method name. The return type is different. This is okay. You can have different return type or even same return type. This doesn't matter. You only have to check whether the parameter list is different. Now in this fourth example, you have three parameters, int, and float. So this is totally different in comparison with above three examples. So this is again a valid example for method overloading. Now in the fifth example, we have same method name. The return type is different. Anyways, this doesn't matter. But the number of parameters are 2 and the sequence of parameters, that is types of parameters, is int. So we already have a method in example number 2 that has two integer parameters in a sequence. The only change we are doing in the fifth example is return type of the method. So this is not a valid example of method overloading. Compiler will throw an error. When you are implementing method overloading, the method name should be same, but the parameter list should be strictly different. Now we have already seen example of constructor overloading. When we write parameterized constructor, we are actually doing constructor overloading, because there is one no parameter constructor and the second constructor can be parameterized constructor, or you can write multiple parameterized constructor with different parameter list. So that is called as constructor overloading. Write a program to demonstrate method overloading. Now in this example, we have class addition and it has three overloaded methods. Method name is add. The first one is no parameters. The second method add is having two integer parameters, and the third method add is having three parameters with data types int, float. So add is overloaded in the class addition. We have a class overload demo and we have defined main method in this class. The first statement is object creation. We are creating object of type addition. We need this object because these are non-static methods and we always call a non-static method using an object. So as soon as this statement is executed, memory is allocated for the object, reference variable A is stored on stack and actual object is stored on the heap. We don't have instance variables defined in this class, so no memory for the instance variables is allocated. Now the next statement is a.add. We are calling add method on object A. As soon as the interpreter finds the method call, control of execution will go to method definition, add method with no parameters, and the code inside add method is executed. That is system.out.println. We are learning method overloading. This statement will be printed to the console. After this execution, control will come back and the next statement is executed a.add with two integer arguments. So internally these arguments are mapped with the method having two integer parameters. Hence control of execution will go to the method definition that is taking two integer parameters. So from here control goes to this definition and the arguments we are passing 10, 34 is captured in these local variables. So inside the memory for local variables belonging to add method that is taking two integer parameters is reserved inside the stack memory area, and the first argument 10 is stored in variable A and the second argument 34 is stored in variable B. Then the control comes inside, code inside is executed system.out.println, and we are printing the addition of two integers 10 plus 34. Hence the value 44 will be directly printed to the console. So the output looks like this. Add method with no parameters prints we are learning method overloading to the console, and the add method with two integer parameters prints A plus B, that is 10 plus 34, that is 44 is printed to the console. Now after this execution, the control will go back and memory from the stack allocated for the local variables will be released. Now the next statement is, this is a println statement, system.out.println, and inside the println statement we are giving a method call. We are writing a.add and we are passing three parameters. First one is of type int, second is of type int, and the third parameter is of type float. Pay little attention over here. Whenever you want to assign a float value, you need to add f to the number. If you are writing 12.5, compiler assumes that it is a double value. If you add f to the number, compiler reads the value as float value. So as soon as the method call is seen, the control of execution will go to the definition of the method which is having matching parameters, that is int, and float. Now suppose if you are not mentioning a float value by explicitly writing f, it is read as double value, and here the data type is float. Double is bigger, float is smaller, so bigger cannot be assigned to smaller data type. It will give an error. That is why mentioning f is mandatory. So from your control of the execution will go to the method definition, and the values passed are stored in these local variables. So the first value 12 is stored in first local variable, second value 10 is stored in second parameter, and the third value 12.5 is stored in third parameter. Memory will be allocated to these local variables belonging to method add with parameters int, float, and the values are stored inside it. After the memory allocation happens, the code inside is written a plus b plus c, that is 12 plus 10 plus 12.5. The value is calculated, which is equal to 34.5. 34.5 is written back to the point from where you get the method call inside the println statement. So the output looks like this. 34.5 is printed to the console. So in this program we have seen what is method overloading. Method overloading is a class has multiple methods with same name but different parameter list, and the list can differ in number of parameters, type of parameters, or both. So we have seen method overloading. Let us have a look on the definition of what is static polymorphism. Static polymorphism is also called as compile time polymorphism, or it is also called as earlier static binding. In compile time polymorphism, object is bound to the method at compile time. It is not bound to the method at runtime like it happens in runtime polymorphism. In static polymorphism, or you can also call it as earlier static binding, object is bound to the method at compile time. This is very important point to remember. The binding which can be resolved at compile time by the compiler is known as static or early binding. JVM checks the method signature and decides which method to call. Now you have overloaded methods, method with same name but different parameter list. So depending upon the argument pass, JVM checks and decides which method to call. Compile time polymorphism is achieved through method overloading.